This is my ED Advocacy Project on finding multiple multiplication strategies to help students. By the end of this video, you will be able to understand how a multiplication problem can work through multiple strategies, and you will be able to understand the purpose of teaching multiple strategies in your classroom. The reason I decided to choose this issue is because oftentimes my students were very frustrated with using just a traditional model. In fact, I did not know that there were multiple strategies to find a common answer for a multiplication problem until teaching this content earlier last year. One piece of cited research that I found to help with my conclusions was from the Australian Association of Mathematics Teachers. They noted that by addressing the issues of how we develop the why around the how of multiplication, it leads students to being fluent users of multiplication for mental and written computation. By building this strong foundation in their multiplication skills, students will be able to have a greater success in their further mathematical courses, as we all know, because our multiplication strategies help us with developing harder concepts as we get into difficult subjects.
Another multiplication strategy that you can often find is called partial products, and I'm going to show you this method with a 2-digit times 1-digit multiplication problem, 23 times 4. So to solve this, you can originally set it up like the traditional method, 23 times 4. Now, partial products means we're finding part of our product or part of our answer at a time. So we need to break up this 23 and put it in expanded form. And to put it in expanded form, by breaking it up in place value, it's going to become 20 plus 3 times 4. 4 is already in its lowest form, so we don't need to do anything else with that. So now when you're multiplying, you can understand that this is not just a 2, but this is 20, so you're multiplying it by 20. So 3 times 4 is 12. There is no carrying. You're just going to go ahead and put your answer. 3 times 4 is 12. And now we know that this is now a 20, not a 2, because it's in our tens place. 4 times 20 is 80. Once you have found your partial products or part of your answer, you're going to add them up to get 92 as your product or your answer. This video is to show you how to work an area model multiplication problem. We're going to start off with a 3-digit number times a 1-digit number. So if you were to ask me to multiply 254 times 5, the first step is that you need to create this number into expanded form. So to put the number in expanded form, you're going to take each place value. So I'm going to break it up and put 200 plus 50 plus 4. So I've now created 254 into expanded form. Now since it's times a 1-digit, I'm only going to have a 1-digit spot right here on my area model. And now we're ready to begin multiplying. So the first thing you're going to do is you're going to multiply each number and put your answer in the following box. So 5 times 200 is going to be 1,000. 5 times 50 is 250, and 5 times 4 is 20. To find the area inside of this model, we're going to need to add all of our partial products together. So I'm going to go out to the side and I'm going to add 1,000 plus 250 plus 20. 0 plus 0 plus 0 is 0. 5 plus 2 is 7. 0 plus 2 is 2. And 1 plus nothing is 1. Don't forget your comma. And your answer or your product is 1,270.
Using area model is a great strategy because it links multiplication to area. It demonstrates the distributive property, models commutativity, and makes the transition to algebraic thinking and reasoning much easier as they get on to higher math concepts. Lattice multiplication is a strategy that can also help you find your product. The pros of using this strategy is that it provides another strategy to solve the multiplication problem. It breaks up multiplication into smaller steps to become more manageable for students, and it's easier for students who struggle with their facts. It keeps information and organizes it in a different way. Now, the cons to using this strategy is that it demands neatness. Students are asked to create a very detailed model with very straight lines, and if you have a child that cannot draw straight to save their life, then it's going to be very difficult for them. And it takes about 15 to 30 seconds longer than some of the other strategies that we have mentioned. Assuming you were taught traditional model multiplication like I was, you know that it is a series of steps to complete the algorithm. Now, during a study, it was found that when the traditional algorithm was used, errors in addition were low, but when you carried, those mistakes accounted for approximately a quarter of all the errors when children got the problem wrong. The study also found that when 7% of the students' errors using the traditional algorithm involved missing one of these simple calculations. So instead of understanding place value like the standard indicates, students are just learning repetitive steps to solve a problem. That's why I am advocating that other multiplication strategies need to be taught in schools. In conclusion, I chose multiplication strategies as an advocacy issue due to the fact that many schools across the state are still teaching only one method like the traditional model. Knowing Gardner's multiple intelligences, we know that every child learns differently. Therefore, teachers should be catering to the needs of their class and providing multiple strategies for their students. I implement these strategies and encourage other math teachers to do the same.